Earth. Our beautiful blue marble, floating in the vast darkness of space. For our entire history, we have believed this is it. The pinnacle, the perfect design. The only place in the cold universe where life could truly flourish. But what if I told you, were we wrong? What if Earth isn't the best place for life? What if it's merely a C-grade apartment in a galaxy full of luxury mansions? Tonight, we aren't just looking for another Earth. We are looking for something better. Scientists have found them. They are called superhabitable worlds. Planets that are older, larger, warmer, and wetter than our own. Worlds where life doesn't just survive, it thrives in ways we can barely imagine. And the most terrifying part? If these worlds exist, and they are better than Earth, then why haven't we heard from the civilizations that should be living there? Are we the first? Or are we simply living on a practice planet while the real action is happening somewhere else? For decades, astronomers have been obsessed with the Goldilocks zone, that narrow band around a star, where it's not too hot, not too cold, but just right for liquid water. We've been hunting for Earth too, a mirror image of ourselves. But Dr. Dirk Schulze-McCouch, an astrobiologist at Washington State University, suggests this approach is fundamentally flawed. It's what we call Earth-centric bias. Think about it. Is Earth really perfect? Our planet has frozen over completely multiple times. We have mass extinctions caused by relatively minor asteroid impacts. We have a star, our Sun, that is actually quite volatile and short-lived. Scientists have now developed a new habitability index, and when they ran the numbers on thousands of known exoplanets, something shocking emerged. Earth scored a 0.829. But out there, in the darkness, are worlds scoring 0.836 and higher. These decimal points represent the difference between a planet that allows life and a planet that wants life. To build a better home, you first need a better furnace. Our Sun is a G-type yellow dwarf. It has served us well, but it has an expiration date. In less than 1 billion years, our Sun will grow roughly 10% brighter. That sounds small, but it's enough to trigger a runaway greenhouse effect that will boil our oceans and sterilize the Earth. In cosmic terms, we are running out of time. Enter the K-type Orange Dwarf stars. These are the silent heroes of the galaxy. Smaller than our Sun, cooler, but infinitely more patient. While our Sun burns out in 10 billion years, an orange dwarf shines steadily for up to 34 billion years. Imagine what evolution could do with an extra 20 billion years. On Earth, it took 4 billion years to get from single cells to us. On a planet orbiting an orange dwarf, evolution could run uninterrupted for 3 times that duration. No boiling oceans, no dying star, just billions of years of refinement. This suggests that the most complex life in the universe isn't orbiting stars like ours, it's orbiting the orange ones. So what does a superhabitable world actually look like? First, make it bigger. About 10% larger than Earth, with about 1.5 times the mass. This isn't just about having more real estate. Mass is gravity, and gravity is a shield. A more massive planet holds onto its atmosphere tighter. It prevents the slow leak of gases into space that is slowly drying out our own world. This extra mass keeps the planet's internal engine running longer. A hot core drives plate tectonics. And while earthquakes seem destructive to us, they are essential for life. They recycle carbon. They refresh the soil. On Earth, our interior is cooling. Eventually, our tectonic plates will lock up. When that happens, the carbon cycle stops and life chokes. A superhabitable world keeps its heart beating for billions of years longer. Now raise the temperature by about 5 degrees Celsius. On Earth, global warming is a threat because our civilization is built for a specific climate. But for biology, warmth is fuel. A superhabitable planet has no ice ages. It is a global tropical paradise. Think of the Amazon rainforest, the most biodiverse place on Earth. Now imagine if the entire planet was the Amazon. More humidity, more clouds, more protection from radiation. This isn't science fiction. We have coordinates. Meet Kepler 442b, located 1,200 light-years away in the constellation Lyra. It orbits an orange dwarf star. It is 33% larger than Earth. It sits perfectly in the habitable zone. It checks almost every box on the superhabitable list. If you could stand on its surface, the light would be softer, slightly orange. The plants might not be green, but red or violet, optimized to absorb the light of their cooler star. The air would be thicker, richer in oxygen. Maybe 25% or 30% oxygen compared to Earth's 21%. One breath would energize you. Flight would be easier for animals. You might see creatures huge in size, supported by the dense atmosphere, soaring through skies that never freeze. Or consider the TRAPPIST-1 system. 7 Earth-sized planets packed together. If life took hold there, asteroid impacts could transfer microbes between worlds, creating an entire solar system of interconnected biospheres. But detecting these worlds is one thing. Understanding what lives there is another. And this is where the science gets truly mind-bending. If a planet creates better conditions, it doesn't just create more life, it creates better life. On Earth, life is a constant struggle against scarcity and disaster. Evolution favors survival of the fittest. But on a superhabitable world where resources are abundant and the climate is stable for eons, evolution might shift its focus. Instead of competition, you might see cooperation on a planetary scale. Biologists speculate about global homeostasis, where the biosphere itself regulates the planet's climate with machine-like precision. The forests don't just grow, they manage the atmosphere. The oxygen levels are calibrated. The water cycles are optimized. It creates a biosphere so efficient, so integrated, that the line between the planet and the life upon it begins to blur. And if evolution has had 8 billion years, twice the age of Earth, to work on the problem of intelligence, what kind of minds would emerge? Would they be tool users like us, or would they develop something stranger? Something that taps into the fundamental fabric of the universe itself? But this leads to a haunting question. If the galaxy is filled with billions of these superhabitable worlds, and if they have been thriving for billions of years longer than Earth, where is everyone? Why is the sky so silent? We look for aliens by searching for radio waves and industrial pollution, the signatures of a young, messy civilization like ours. But scientists suggest we are looking for the wrong things. A civilization that has survived on a superhabitable world for 5 billion years wouldn't be loud. They would be efficient. They wouldn't conquer nature. They would integrate with it. Their energy systems would leave no waste heat. Their atmosphere wouldn't show pollution, but a suspicious perfection. Ratios of gases so precisely balanced that nature alone couldn't produce them. We aren't looking for machines. We should be looking for planetary engineering. Or perhaps we should be looking for something even more subtle, something occurring at the quantum level. Here on Earth, quantum mechanics is fragile. Quantum states the ability for particles to be in 2 places at once, or to communicate instantly across distances, usually collapse the moment they interact with a warm, chaotic environment. But remember, superhabitable worlds are stable, they are protected. In these ultra-stable environments, shielding from radiation and magnetic interference might allow biology to do something impossible on Earth. Harness the quantum field. Imagine a brain that doesn't just use chemical signals, but uses quantum tunneling to teleport thoughts across neural networks instantly. On Earth, our brains are biological computers. On a superhabitable world, life might have evolved into a quantum computer, processing information millions of times faster, detecting magnetic fields, sensing the curvature of space-time itself. This isn't just intelligence. This is a new state of existence. And if individual organisms can access this quantum network, what happens when they connect? We define consciousness as something that happens inside a single skull. But on a world where root systems, atmospheric gases, and ocean currents are all integrated through quantum feedbacks, the planet itself might wake up. We call it the planetary mind. A collective consciousness where the boundary between the individual and the environment dissolves. They wouldn't need to build spaceships to explore the universe. If their minds are entangled with the quantum vacuum, they might be able to project their consciousness across the galaxy without ever leaving their home. While we shout into the void with radio waves, waiting for a reply, they might be communicating through the fabric of space-time itself, a conversation we are too primitive to even hear. So where does that leave us? Living on a small, anxious rock, orbiting a volatile yellow star, in a universe filled with mansions. It is humbling. It forces us to admit that Earth is not the center of the stage. It might just be the waiting room. A practice planet, where life learns the hard lessons of survival before it is ready for something greater. But there is beauty in the struggle. Because Earth is hard, we learn to fight. Because our planet is imperfect, we learn to dream of better ones. The superhabitable worlds are out there, waiting. They are not just scientific curiosities. They are a glimpse of our future, a blueprint of what we could become if we can just survive our adolescence. The universe is not dead. It is waiting for us to grow up. And the search has only just begun. If you want to join us on this journey through the cosmos, subscribe and turn on notifications. I'm the Stellar Diary, and I'll see you in the next discovery.